Hi, my name is Victoria Blanton, and I am a second year of astrophysics student. I am currently doing research with Dr. Pisano, the chair of the Physics and Astronomy department. We are in the process of constructing a radio telescope that hopefully will be able to receive radio waves from space and construct a map of neutral hydrogen. Now to start, what exactly is neutral hydrogen? Neutral hydrogen, otherwise known as H1, is a gas that exists in the universe due to the formation and destruction of stars. It exists in clouds that have the energy to dissociate molecular hydrogen into atoms, but not enough to give it any kind of charge. It currently fills the space between stars and other celestial bodies. When those objects move throughout space, the H1 follows their movements like ripples in water. Neutral hydrogen produces a unique radio wave frequency that we are able to analyze and receive through radio telescopes. Because of it, we are able to determine the structure and movement of our galaxy. It is incredibly important in the world of astronomy. Because of neutral hydrogen, we can deduce many aspects of our galaxy, like size and weight and shape, through the patterns of H1. As of now, humans aren't able to construct any kind of ship that would be able to travel outside of the Milky Way due to how large it is, give or take 100 million light years, which means that we are not able to take a picture of our home galaxy. To make up for this, we use H1 to detect the placement of stars and how they move, so we can make assumptions about the evolution and shape of the Milky Way. The goal of my project is to test the accuracy of a radio telescope created by creating a map of neutral hydrogen visible from our sky. We are currently using a guided construction manual created by professors and professional astronomers from Green Bank Observatory, the National Science Foundation, and West Virginia University. The point of the guide is that anyone, even those with limited experience, can construct the telescope if given the financial means to do so. The telescope consists of only a few parts. The horn is a large, square, pyramidal cone that is made of aluminum insulation. Its purpose is to receive the radio waves and let the next piece, the can, read them. This is the part of the telescope that is the most difficult to build and is where the more complex telescopes would keep others from making their own. The can is a small metal box attached to the smaller end of the horn. It contains all of the electronic pieces of the telescope. First, we have the software-defined radio, or SDR, which is a method of taking traditional hardware, like amplifiers and modulators, and putting it into a single piece of software on a computer or other device. For us, it's a small external device called an AirSpy. Next, we have a low-noise amplifier, or LNA, which takes a relatively weak signal and boosts it without sacrificing quality so we can analyze it. This is the most complex part of the telescope, as we had to build the entire LNA circuit on our own. For those familiar with soldering, you have a relative idea of how simple the most complex piece of the telescope is, which is our entire goal. For those not familiar with soldering is the technique of taking a heated metal rod, the soldering iron, and melting a small piece of metal, usually lead or tin, to connect two other pieces of metal, usually copper. For my research, this is taking a bare circuit board and individually soldering smaller pieces specific to the purpose that we want the circuit to serve. Those two pieces are connected to the computer through a DSPIRA software, a form of digital signal processing, specifically digital signal processing in radio astronomy, which is the steps of taking analog data and reconstructing it into new forms. A common example is how TVs would work. We are currently in the process of fully connecting all of the CAN pieces together, so we have yet to see what our data would look like, but the final pieces are simply the cradle and the stand, two simple wooden structures that support the horn in the can and allow us to adjust it for positioning. Once the construction of the telescope is complete, we will attempt to collect data that we receive from our telescope. We're planning on comparing the maps that we make with pre-existing maps to find the accuracy of the telescope before we use it for our own purposes. The telescope will hopefully be used in the descriptive astronomy class here at WVU. We hope to not only add information to the world of astronomy, but encourage others to do the same. Once our testing is finished, we plan on also submitting any suggestions or corrections to the original creators so that the entire process is easier to use. In the astronomy community, we are always seeking new ways to make the study more accessible and inclusive to all people, and we are able to do this through simple projects like the creation of a radio telescope for class use. Astronomy can seem like a very complex and daunting topic, but overall, it's nothing more than some people hoping to learn more about the vast universe we call home. Thank you.